Hi everyone. Today we'll be looking at some different properties of angles depending on the angle relationships. For every lesson, make sure to write down the focused learning target. Here's today's learning goal. Given properties of angles, I will be able to apply them to find missing angle measures. And at any time, if you need more time to write something down, remember you can pause the video and rewind as necessary. First, let's take a look at how to name angles. There are a few ways to name angles, so let's take a look. So here we have an angle, and let's take a look at how we can name the angle in different ways. One simple way to name this angle is angle B, since the angle mark is at the point B. Another way to name this angle is to start at A, go through B, and end at C. So we can also name this angle as angle ABC. We can also go in the opposite direction, starting at C, going through B, and ending at A. In this case, the angle would be called angle CBA. Keep in mind that these are still all talking about the same angle, they're just written differently. Also notice here that there's like the little 1. It might be a little hard to see on your screen, but we can also name this angle as angle 1 since it's labeled with the number 1. Although these are all correct ways to label the angle, I would recommend using the bottom 3 options to name an angle. And I'll talk a little more about why we don't want to use something like angle B in the upcoming example. Let's take a look at an example. And when you're working through examples in your notebook, be sure to write down the question as well as any associated images as well. It doesn't have to be an exact copy, but try to do like a pretty similar sketch. So here we're going to name the selected angle. So we have this selected angle right here that I just highlighted. So let's name this a few different ways. Notice that while it's at the point B, I don't want to name it angle B because I'm going to be like, wait, which exact angle am I talking about? So I want to be a little more specific. This angle starts at A, goes through B, and then ends at D. So one way to name this angle is as angle ABD. But we can also go the other way. So what we can do is start at D, go through B, and end at A. So we can also name this angle as angle DBA. And we can also name this angle angle 2. So there are a few ways to name an angle, and now let's take a look at some angle relationships. Let's first talk about supplementary angles. 2 angles are supplementary when they add up to 180 degrees. So supplementary angles will create a straight line. So here's an example of supplementary angles. These 2 angles are supplementary because 140 degrees plus 40 degrees equals 180 degrees. So let's take a look at some examples using the properties of supplementary angles. So in our first example for this section, we are asked to find the missing angle measure. Notice that we have a set of supplementary angles, so let's use the fact that they'll add up to 180 degrees. So we are asked to find the missing angle measure. So that's this angle right here with the question mark. I'm going to use X instead of a question mark. But yeah, so the measure of angle 1 plus the measure of angle 2 equals 180 degrees because they're supplementary angles. And I know that the measure of angle 1 is 32 degrees. but I'm not sure about the measure of angle 2. So again, I'm going to use x to represent that measure. So I have that 32 degrees plus x equals 180 degrees. Similar to an algebra problem, it's like solving for x. So I want to make x by itself. I can do this by subtracting 32 degrees from both sides. This will cancel out, and I'm left with x equals 180 degrees minus 32 degrees, which is 148 degrees. So x represented the missing angle measure, and the missing angle measure is the measure of angle 2. So I'll just rewrite it. The measure of angle 2 is 148 degrees. We've found the missing measure by using the fact that the two angles here are supplementary. Here's our second example. We are asked to find the angle measure of angle 2. So in general, make sure you're reading the problem carefully, and I'll talk a little bit more about why as we go through this example. So here I have to find the angle measure of angle 2, which is this angle over here. And notice how angle 1 and angle 2 are supplementary. So we're going to use that property. So the measure of angle 1 plus the measure of angle 2 equals 180 degrees, since they're supplementary angles. So let's replace the angles with the given values. So I know the measure of angle 1 is 65 degrees, and the measure of angle 2 is 6x plus 1 degrees. And these two add up to 180 degrees. So in this step, I just replace the measure of angle 1 with the given 65 degrees, and the measure of angle 2 with the given 6x plus 1 degrees. And now let's start simplifying a bit. So here we can combine the 65 and the 1. We can add them together. So we're going to have 6x plus 66 degrees equals 180 degrees. And I'm going to continue solving for x. So I'm going to subtract 66 degrees from both sides. This cancels out over here, and I'm left with 6x degrees equals, let's see, 180 minus 66. So that's going to be 114 degrees. I've almost isolated x. Next, I'll divide both sides by 6. And I'm left with x equals, so 114 divided by 6 is 19. But right here, you might be tempted to stop, but let's read over the example again. The problem asks us to find the angle measure of angle 2. So although we've solved for x, that's not enough for this problem. Some examples, it'll just ask you to solve for x, but in this case, we have to use the fact that we found x in order to find the angle measure of angle 2. So we just solved for x and found that x equals 19. So let me write that down right here. X equals 19, and we're going to use this to find the actual angle measure of angle 2. So the measure of angle 2 is equal to 6x plus 1 degrees. And since we just solved for x, we're going to replace x with that value. So 6 times 19 plus 1 degrees. And from here, we're just going to simplify. 6 times 19 equals 114. So let me write that here. 114 plus 1 degrees. Plus 1 degrees just sounds so weird. Anyway, so I'm going to combine this. I got 115 degrees. So I know that the measure of angle 2 equals 115 degrees. So now I've solved for the entire example because I've found the angle measure of angle 2. And this is me just checking my work on the side. I can easily check by making sure the two angles add up to 180 degrees. So 65 degrees plus 115 degrees does equal 180 degrees. So we've looked at supplementary angles. Next, let's take a look at vertical angles. So vertical angles are the angles opposite each other when two lines cross. So what do they look like? Here we have two lines that cross and thus creating four angles. Angles 1 and 3 are vertical angles because they are opposite of each other. And we have another pair of vertical angles, angles 2 and 4. Notice how they are opposite of each other. So a property of vertical angles is that they are congruent to each other. So the angles are congruent, which means that they share the same angle measure. And we'll be discussing as to why vertical angles are congruent, maybe as a group discussion or something. So here we have the same set of angles as earlier. And I know that angle 1 and angle 3 are congruent to each other because they're vertical angles. To denote that something is congruent, just use the equal symbol with the little squiggly on top. We also know that angle 2 is congruent to angle 4 because this is another pair of vertical angles. So let's use the property of vertical angles and take a look at some examples. So for our first example here, we will find the angle measure of angle 1. How can we use the idea of vertical angles to find the missing angle measure? So for this example, we are asked to find the angle measure of angle 1, that's this one right here. And notice how angle 1 and angle 3 are vertical angles. That means they're congruent to each other. So angle 1 is congruent to angle 3. That means they share the same angle value. So the measure of angle 1 is equal to the measure of angle 3. We're not sure what the measure of angle 1 is. That's actually what we're looking for. But we do know the measure of angle 3. It's 50 degrees. So the measure of angle 1 is also 50 degrees. Again, because vertical angles are congruent to each other, so they have the same angle measure. So we found the angle measure of angle 1, it's 50 degrees. Let's look at one more example together. For this example, it says to solve for x. So in this problem, we're going to solve for x, and that's it. Again, we're going to use the idea of vertical angles. So what vertical angle pair might we be using here? So for this example, I notice that angle 2 and angle 4 are vertical angles. That means angle 2 and angle 4 are congruent to each other. So they share the same angle measure. The measure of angle 2 equals the measure of angle 4. The measure of angle 2 is 4x plus 2 degrees. So let me write that here. Equals the measure of angle 4, which is 58 degrees. So now we've set up an equation and we're going to solve for x. First, we'll subtract 2 from both sides. We are left with 4x degrees equals 56 degrees. Next, we'll divide both sides by 4. And we find that x equals 56 divided by 4, which is 14. So we've solved for x. So for this example, we're done. X equals 14. So let's go over what we talked about today. And these quick review portions, you don't have to necessarily write down in your notebook. Right, so we talked about how two angles are supplementary if they add up to 180 degrees. And we also talked about vertical angles. Vertical angles are angles opposite of each other when two lines cross. Vertical angles are congruent to each other. That is, they have the same angle measure. Great job today. And now please take a picture of all of your notes and submit them to Canvas. Thank you.